This is the continuation of the previous lecture, so where we are talking about the theorems, superposition theorem, Norton's theorem, and Thevenin's theorem. And in this lecture, we are going to solve few problems on this superposition theorem and Thevenin's. Now, in this question, find I naught V naught using superposition theorem. Right? So from this circuit, we need to find the I naught and V naught using superposition theorem. See this. There is a dependent source which is the linear dependent source. It is dependent on the I naught, not I naught square. So then we can apply the superposition principle here. Now 6 amperes alone. So take one more. So this is, first we'll see 6 amperes alone. Now if I draw the circuit, so this is 6 ampere, 40 ohms. This is 10 ohms. Dependent source always will exist, that is 4 I naught. This is 20 ohms. This is should be short circuited because voltage we are making 0. Now this is I naught 1 I am taking as, and this is plus minus V naught 1. So whenever it is I naught 1, so here I naught will become I naught 1. Now in this case we have to find this. So what we do go for the nodal analysis, that is I will assume as the V1 here and this is V2 here. Alright, now minus 6 plus V1 by 10 plus V1 minus V2 by 10 equal to 0. So 2V1 by 10 minus V2 by 10 is equal to 6, or we can write like this: 2V1 minus V2 is equal to 60. Equation 1. Similarly, apply nodal analysis here. So my V2 minus V1 by 10 minus 4 I naught 1, because this is incoming, plus V2 minus 0 by 20 is equal to 0. So minus V1 by 10 plus 3 by 20 V2 is equal to 4 I naught 1. But we need to know what is I naught 1 because it is the dependent. So dependent on this here, I naught 1. I naught 1 is nothing but V1 minus V2 by 10. So 4 into V1 minus V2 by 10. Right? If I rearrange this one, so it will become minus V1 plus 3 by 2 V2 is equal to 4V1 minus 4V2. So 4V1 is going this side, so minus 5V1 plus, so 3 by 2 plus 4, so 5.5, so 5.5 V2 is equal to 0. This is the equation 2. Now we can solve for V1 and V2, then we can get the values. Now solving this equation 1 and 2, we will get V1 and V2 as 55 volts and 50 volts. But we need I naught 1 as well as V naught 1. Now it's very simple. I naught 1 is equal to V1 minus V2 by 10. What is V1? 55 minus 50 by 10. So 0.5 ampere. Similarly, V naught 1 is difference between V1 minus V2. So this is 5 volt. This is one part. The second part is considering 30 volt source alone. So the current will be open circuit. This here, this is 40 ohms, this is 10 ohms, again this is 4 I naught, this is 20 ohms, this is minus plus 30 volts. Right? Now so again this is I naught 2 plus minus V naught 2. Now if you see, this is here will have only single node, right? Because this is the current is 0, so whatever the current is coming, it is going in this only, so only single node. So apply node analysis. So V by 50, this is 10 plus 40, 50 minus 4 I naught 2, because this is I naught 2, so this is also I naught 2, 4 I naught 2 plus V plus 30 by 20 equal to 0. So if I take V common, this is 1 by 50 plus 1 by 20 minus 4 I02 is equal to minus 3 by 2. But we need I02. I02 is, this is incoming, right? So can I make like this? I02 is equal to 0 minus V by 50. So just substitute here, we will get the answer. So V 1 by 50 plus 1 by 20 minus 4 into minus V by 50 is equal to minus 3 by 2. So again if I take V common, 1 by 50 plus 1 by 20 plus 4 by 50 is equal to minus 3 by 2. So what is the V? V is, so 1 by 50 plus 1 by 20 plus 4 divided by 50 minus 1.5 divided by minus 1.5 divided by 0.15. So V is, we got minus 10 volts, but we don't want this one, we need the I02 and I0. So just now we found I02 is equal to minus V by 50. So minus V means minus 10. So this is 1 by 5 amperes. Similarly, what is V02? V02, we see here this current into this resistance. So simply 1 by 5 into 10. So it's nothing but 2 volts. Now by superposition principle, V0 is equal to V01 plus V02. What is V01? We got 5 plus 2. This is 7 volt. Similarly, I0 is I01 plus I02. So I01 we got 0.5 ampere plus I02 we got 0.2 ampere. So answer is 0.7 ampere. So this is the superposition theorem. So we can apply superposition theorem for dependent sources also. Whenever there is a dependent source in the circuit, so we can apply the superposition principle when two or more independent sources are there, right? Next we will see the Thevenin's theorem. So this is one problem which is having a dependence. So when independent and dependent sources are there, when independent and dependent sources are there, then what is the procedure to find VTH and RTH? Now we are going to solve two problems on Thevenin's theorem. So these two problems are very important because in this circuit there is a dependent source. Whenever there is a independent as well as dependent sources are there, how to find VTH and RTH? So very important one. So finding VTH is same as the previous problem we have solved in the previous lecture. So see, at this terminals A and B we need to find RTH and VTH. So simply take it as VTH here, right? So this is open. Now this is a voltage as VTH, right? Now if I assume, see, this is already given V0 and this V0 is dependent here 0.25 V0. So this is, I am assuming V0. Now apply nodal analysis. So at this node, at V0, so V0 minus 18 by 6 plus V0 by 3 minus, this is incoming, this current is incoming, so minus 0.25 V0, and here plus V0 minus VTH by 2 is equal to 0. Now if I rearrange, V0 1 by 6 plus 1 by 3 minus 0.25 plus 0.5 is this one, minus VTH by 2 is equal to 3 because 6 3s are 18. Now if I rearrange, 1 by 6 plus 1 by 3, so this is 6, 1 plus 2, 3, right? Plus 0.25 minus 1 by 2 VTH equal to 3. So I'll make it as like this only, 1. Now what is the one more equation we will get at this node? At this node only these two branches are there because this current is 0. So VTH minus at VTH. VTH minus V0 by 2 plus 0.25 times of V0 equal to 0. See, VTH minus V0 by 2, this is 0.25 V0. So this is the equation we got. So minus V0 by 2 plus 0.25. So that is minus 0.25 V0 plus 1 by 2 VTH equal to 0. This is the equation 2. When we solve these two, we'll get the V0 and VTH. Now how to solve? Minus 1 by 2H minus 1 by 2. This will be cancelled if I add 1 plus 2. So this will be cancelled. That means if I take V0 common, this is 3 by 6. That is 1 by 2 plus 0.25 minus 0.25. This will be cancelled is equal to 3. Again this will be cancelled. So directly V0 is equal to 6 volt. Now we got V0 6 volt. Then we can find VTH. So from this equation 1 by 2 VTH is equal to 0.25 times of V0. So 0.25 means 1 by 4 into 6. This is 1 by 2 VTH. So 2 2s, 2 3s. So what is VTH? VTH is equal to 3 volts. Now how to find RTH? That is a very important one. Now to find RTH, there are two methods. One method is find the Norton current or short circuit current ISC, right? So when I find ISC, then I can have this VTH by ISC as our RTH. So method 1, find ISC or IN across A dash B. Then RTH is equal to VTH by ISC or IN, right? Now how to find? So if I make a short circuit like this, this is the ISC. Now when we make short circuit, VTH is becoming 0, right? Now already we derived the expressions. So in those expressions, if I substitute VTH is 0, this is the first expression. In this, if I substitute VTH is 0, I will get V0, right? Once I get V0, I will get the ISC. So from this expression, if I substitute VTH is equal to 0, so this is what? V0 into 1 by 3 by 6, that is 1 by 2 plus 0.25, that is 0.75 minus 0 is equal to 3. So what is V0? So 3 by 4. So V0 is equal to 4 volt. Now once we know V0 4 volt, then from the circuit, see here. So this is the 4 volt. What is this current? See, 0.25 times of V0. So 0.25 times of 4. So I will get 1 ampere. Yes or no? So similarly, I know V0. So this is the 0 volt. What is this current? So this current is incoming, right? So V0 minus 0 by 2, that is 4 by 2, that is 2 ampere is incoming. So this is 2 ampere is incoming. So 1 ampere is outgoing and 2 ampere is incoming. So what is this current? So apply KCL. Now if I apply KCL at output, ISC is outgoing plus 1 ampere is also outgoing, minus 2 is incoming, so 0. What is ISC? It is simply 1 ampere. Now what is VTH by RTH? VTH we got 3 volts, so RTH is equal to VTH by ISC. So VTH is 3, ISC is 1. So what is this? RTH is equal to 3 ohms. So this is one way of doing the finding for VTH and RTH. So whenever there is a dependent source, I will go for VTH as well as ISC. Then VTH by ISC is RTH. For finding a VTH, so simply open, then apply nodal analysis, we will get VTH. Now we have seen method 1. Now method 2 we'll see. So method 2, same we should get, that is 3 ohms. That is method 2. Apply a test voltage and test current at A comma B or A dash B. When we are applying this test voltage and test current, make independent sources 0, right? So by if I find RTH, that is V test voltage by test current, right? Now if I take the circuit again, this is like this. So 18 volts is there, so it will become short circuit. And there is a 6 ohms. Next, this is 3 ohm, but there is a V0. This is a resistance, and there is a dependent source which is going like this, which is 0.25 times of V0, right? And this is 2 ohms. Now here I'll apply a test voltage and a test current. Then if I find Vt by It, so we can find the RTH. So simple again. This is node voltage Vt. This is the node voltage V0. Now we'll apply nodal equations. Then we'll get one by one. So I'm writing here at V0. So at V0, so it's simple. V0 by 6 plus V0 by 3 minus 1 by 4 V0. I'm writing directly 0.25 as 1 by 4 plus V0 minus Vt by 2 equal to 0. Right? There is no dependent source. So directly V0 is 1 by 6 plus 1 by 3 plus 1 by 2 minus 1 by 4 is equal to Vt by 2 or V0. So 1 by 6 plus 1 by 3. So this is 3 by 6 plus 1 by 4 I will get here. This is V0 by 2. So if I take LCM again, so 24, 12 plus 6 is equal to V0 by 2. So 2 12, so V0 is equal to, this is Vt, not V0. Vt into 12 by 18, right? So 2 Vt by 3. So this is the V0, right? Now similarly at Vt, what is the equation? So Vt minus V0 by 2 minus It, because this is current I know, plus 0.25 times of V0 equal to 0, right? Now again if I take Vt common, so Vt by 2 plus, if I take V0 common, this is 1 by 4 minus 1 by 2 is equal to It. So what is this V0? V0 already we know, that is 2 by 3 Vt into 1 by 4 minus 1 by 2 minus 1 by 4 is equal to It. So this is Vt by 2. Now if you see this expression, only Vt and It, then we can rearrange this one. So if I take Vt common, 1 by 2 minus 1 by 6 is equal to Vt, because 2 by 3 into 1 by 4, so 2 2, so 1 by 6. This is current It. So what is Vt by It? So first we will find this one. So 6, 3 minus 1 is equal to It. So what is Vt by It? Vt by It is equal to RTH is equal to 6 by 2 is equal to 3 volts. Now if you observe what we got previously as 3 ohms. Now also we got 3 ohms. So we can use two methods. If you are applying the test voltage and test current, make independent sources 0. If you are finding the ISC, don't make independent sources 0. That just to find ISC, then Vt by ISC or Vth by ISC is RTH, right? This is one more problem we will see. If it is having only dependent sources, finding Thevenin equivalent or Norton equivalent. Now one more problem we'll see. Suppose the circuit is having only dependent sources, no independent source. Now remember, whenever there is a only dependent source, Thevenin Thevenins or Norton's equivalent will be only the resistance, right? That is like this. So if it is a Thevenin, so it will be something like this, RTH. If it is a Norton, it will be like this. So only Thevenin equivalent, Thevenin resistance value, RTH is equal to RN here. Only will get resistance because there is no independent source, so we will not get any VTH and ITH. So even though if you find VTH, so we will get this is 0. Even if you get if you find IN, we will get 0 only because no independent sources are there. Now how to find this RTH? Whenever there is a dependent source, just now we solved, we have to apply a test voltage, a test current. Now what to do? Now this 10 Ix is there, so Ix is dependent where, so that should be mentioned here. This is Ix, right? Otherwise we cannot find the RTH. Now apply a voltage V here. Now apply nodal analysis. V minus 10 Ix by 4 plus V by 2, and this current is minus IT is equal to 0. So if I take V common, that is 1 by 4 plus 1 by 2. So we can make it as 3 by 4 minus this one 10 by 4. So we can say 5 by 2 Ix is equal to IT. That is equation 1. So IT here, and this is only V, right? So here Ix is there, here V. So we need one more expression. This is here. If you see this IT is equal to, this is nothing but Vt minus V by 1. Or we can say V is equal to Vt minus IT. This is equation 2. Now if I substitute here, I will get Vt minus IT into 3 by 4 minus 5 by 2 Ix equal to IT. Still there is a one more unknown, that is Ix. Now what is Ix? If you see the circuit, this is Ix. So I can make Ix is equal to V by 2. Again V means we have to substitute this one, Vt minus It by 2. So if I substitute back, what I will get? Vt minus It into 3 by 4 minus 5 by 2 into this one, Vt minus It by 2 is equal to It. Now if I rearrange, I will get the RThevenin. So if I take Vt common, 3 by 4 minus 5 by 4 is equal to, if I take It common, minus 3 by 4 is coming there, so it is 1 plus 3 by 4, and here also minus 5 by 4. So minus of minus plus, it is coming there, minus 5 by 4. So what is this? 3 by 4 minus 5 by 4. So it is minus 2 by 4 is equal to It. So 4 plus 3 minus 5 by 4. So this is the cancel. So what is Vt by It? It is 4 plus this 7 minus 5. This is 2 by minus 2. So what is RTH? RTH is equal to minus 1 ohm. Remember, RTH can be negative when there is a dependent sources, right? So this is how to find the Thevenin equivalent when all dependent sources are there, only dependent sources, right? So in dependent sources we can have negative resistance also. So this question came in GATE 2018. It's not this question, this type of question where we get the negative resistance, right? Remember, whenever there is only dependent sources are there, apply test voltage, test current, find Vt by It. That is the R equivalent we can find, right? So this is about the Thevenins and the Nortons as well as superposition theorem, right? So I will upload the problem sheets. So I will upload problem sheet, right, in our blog, right? So just go and download it and do the practice, right? If you are having any problem, so please post a comment in our blog, right? So blog is learningiseverything.blogspot.in. Learningiseverything.blogspot.in. Okay, so we can discuss there. Even if I do some something rank calculations, you can make sure that so you are not doing that calculation. So you have to do once again. So just listen the concept, just pause the video, do on your own, then verify the results, right? So if I suppose your answer and my answer is somewhat different, just go one more time, still you are getting same answer, just post a comment that so I did a mistake, right? So I'll see one more time, then we see which one is correct or wrong, right? So that is about this one.